considered Earth's twin sister, but the biggest difference between these twins is life. However, that distance was bridged when American scientists found phosphine gas, suggesting traces of life in Venus's atmosphere. This discovery was called the most significant development in the search for extraterrestrial life by NASA's head. But few know that the Soviet Union previously spent 30 years exploring this planet near the Sun and achieved unparalleled successes that no other nation has matched. So what did they find on Venus? Could there have been life forms on Venus that the Soviets concealed during their exploration? The interplanetary probes Pioneer and Voyager, launched by the US in the 1970s to explore distant planets, are often praised as historical milestones. Similarly, updates on NASA's Mars rovers like Curiosity and Perseverance flood the news, even personified into vivid stories. Meanwhile, the Soviet Union's ambitious Venus exploration missions have fallen into obscurity. From the dawn of the space era in the late 1950s, Soviet scientists designed and built a series of Venus probes. For nearly 30 years, they constructed and launched interplanetary spacecraft to Venus under the Venera program. This was truly an impressive feat even by today's standards. In the early 1960s, the Cold War was at its peak, and the space race was intensely fierce. Firsts. At that time, their rockets had better thrust than America's, allowing them to build and launch larger spacecraft, both manned and unmanned. With 4-stage rockets and advanced telemetry systems, the Soviets could conduct missions to hard-to-reach planets near the Sun. In 1961, the Soviet Union launched the Venera 1 spacecraft. Its goal was to orbit Venus, but the first version failed to leave Earth. The second version encountered sensor issues, losing contact with Earth just 100,000 kilometers from its target. This was the first interplanetary probe to combine all necessary spacecraft equipment, including solar panels, a high-gate antenna, a 3-axis stabilizer, and a course-correction engine. Next was Venera 2, built to fly by Venus. Intended to gather and transmit data to Earth, it approached within about 24,000 kilometers of Venus but overheated and ceased communication. Venera 3 crashed onto Venus's surface instead of landing as planned, becoming the first spacecraft to impact another planet. Atmospheric pressure. It provided the first chemical analysis of Venus. Venera 4 also detected a weak magnetic field and no radiation belt. The outer atmosphere contained much hydrogen and no atomic oxygen. The probe sent the first direct measurements proving Venus is extremely hot, its atmosphere much denser than expected, and it lost most of its water long ago. Atmosphere and pressure but could not get closer than 18 kilometers from the planet. Venera 7 was the first spacecraft to land softly on Venus's surface and successfully transmit data from another planet to Earth. The spacecraft launched on August 17, 1970, and entered Venus's atmosphere 4 months later. Although designed to survive Venus's extreme conditions, its parachute malfunctioned just before landing. It deployed at 60 kilometers as planned but failed minutes later, causing a faster than expected descent. Ultimately, though completely damaged and hitting the ground at 59 kilometers per hour, tumbling and misaligning the radio antenna, the weak signal was still receivable via telemetry before it died. Data collected was analyzed weeks later, revealing temperature and pressure on Venus. For 23 minutes, Venera 7 endured temperatures up to 475 degrees Celsius. The Soviets were adept at concealment, as Venera 7 should have been Venera 17. Before that, 10 other spacecraft had disintegrated in space before reaching Venus, some even exploding mid-air or burning up during Earth's atmospheric re-entry. The Soviets often renamed space missions when they failed. Even upon reaching Venus, the terrifying surface pressure haunted even the most experienced designers. As atmosphere, like flattening a tin can, the Soviets realized how horrific Venus. Learning from past failures, they built a 5-ton metal spacecraft capable of withstanding Venus's pressure. But despite being tank-like, it lasted only 53 minutes. This was Venera 9, the first to photograph another planet's surface. In October 1975, humanity officially met Venus. Venera 9 captured this image, showing a white object at the bottom as part of the lander. The distortion is due to Venera's imaging system. The surface is angular and partly weathered, with rocks 30 to 40 centimeters in diameter dominating the landscape, many half buried. The horizon is visible at the top left and right. Venera 10 also landed successfully shortly after. During its 65 minutes of surface operation, it sent this image to Earth. The sun was near the zenith, with light similar to a cloudy day on Earth. Objects at the image's bottom are spacecraft parts. The image shows flat rocks partly covered by fine-grained material, resembling an earthly lava field, with a large rock over 2 meters long in front. Later Venera flights extended into the 1980s, helping scientists better understand Venus's geological processes. Venera 11 and 12 both detected frequent lightning and thunder here. Venera 13 and 14 were equipped with microphones to record sound during landing on Venus. Thus, this was also the first time humans captured audio on another planet. Images from the Venera missions show a planet with a unique, cracked landscape under faint, bluish light. The planet we thought was covered by oceans and similar to Earth turned out to be an alien world with violent storms. As the Cold War waned, the Soviet space program slowed, and they eventually halted Venus missions. In 1985, the Soviet Union ended Venus exploration with the dual Vega spacecraft. Each deployed giant balloons carrying scientific instruments. Vega left a legendary final mark as the only robotic missions to float in Venus's yellow atmosphere, hoping to find traces of life there. The Vega mission was a fresh breeze, backed by huge funds and cooperation commitments with 8 European countries. Vega evokes images of giant parachutes. Its timing was perfected so balloons could deploy deep in the atmosphere. That's what researchers now exclaim upon learning Vega 2. Vega 2's journey was tumultuous, enduring sulfuric acid rainstorms below. And for the first time in the history of space exploration, scientists have recorded valuable data about metal rain on an gas-giant planet. Contact with Vega 2 was lost around March 1987. In reality, no one knows how long the probe traveled after the last connection. Scientists speculate that the indestructible probe was incinerated and exploded due to a planet that deceived human expectations. Scientists believe that Vega, like previous missions, exhausted its energy and then simply watched the solar corona until it disintegrated. Vega 1 exploded after a mysterious power failure. while Vega 2 lasted longer, managing to collect samples from the surface of Venus, astonishing the scientific community with the frozen traces of molten magma bodies. Later missions ended, and the Soviet Union realized that searching for life on Venus was futile, gradually losing interest in other missions. And this planet was forgotten for a relatively long time. Recently, Venus has heated up again as Russia, the successor state to the Soviet Union, announced it would continue its exploration program. In 2020, Dmitry Rogozin, head of the Russian space corporation Roscosmos, stated, "We are discussing the continuation of Venus exploration. We consider Venus a Russian planet, so we cannot fall behind." Many projects for Venus missions are included in the Russian government's space exploration program for 2021 to 2030. Russia has also planned a joint mission with the United States named Venera D on this planet. S statement came a day after scientists revealed that a gas on Earth called phosphine had been detected in Venus. Research conducted by Professor Jane Greaves of Cardiff University and colleagues. Greaves said the discovery of phosphine on Venus elevates the importance of studying this planet. It is now ranked as one of the most worthy planets to study in the solar system, alongside Mars and water-bearing moons like Enceladus and Europa. Phosphine gas was detected in the upper atmosphere of Venus, where conditions are cooler and less acidic than the surface, with air pressure similar to Earth's atmosphere. At high altitudes, Venusian winds move in a circular pattern from the equator toward the north, toward the poles. Such air circulation patterns are called circulation, Hadley cells, and this phenomenon also exists on Earth, causing trade winds. As scientists explained in the press conference, small organisms, possibly microorganisms, could circulate through Hadley cells and endure harsh conditions in Venus's atmosphere. The hypothesis that life could exist in Venus's harsh clouds may be surprising, although it is not unprecedented. On Earth, there are also extremophiles, meaning life forms adapted to similarly harsh conditions. Although there is much debate among researchers about this hypothesis, the discovery has sparked interest in the idea of life on Venus, an environment famously toxic like hell. New missions to investigate Venus could best help us understand whether life exists there. It may take several years to get an answer, but the recently published scientific findings suggest perhaps we have different perspectives on signs of life on living Venus. According to an analysis led by astrobiologist John Halsworth from Queen's University Belfast, the lack of water in Venus's clouds prevents life from inhabiting there, or at least life as we know it simply would not have enough water to function. Calculating water activity, a thermodynamic parameter effectively equivalent to relative humidity in the atmosphere. Researchers found that Venus's atmosphere is too dry for Earth-like living organisms to survive. Water activity serves as a strong determinant of microbial cell function and thus a key factor in habitability. Water activity is measured on a scale from a minimum of 0 to a maximum of 1, similar to 100% humidity. As far as scientists know, biological functions in organisms cease below a water activity of 0.585, with fungi Aspergillus penicillioides showing the lowest known limit. Unfortunately, Venus's dry clouds are largely composed of sulfuric acid droplets, not even close to 0.585 in water activity, being around less than or equal to 0.004. In other words, Venus's atmosphere is over 100 times drier than the hypothetical threshold proposed. By the same measure, Mars's atmosphere can also be considered too dry for life to function, although its water activity level is less than or equal to 0.537, only slightly lower within the habitable range compared to Venus. Regarding water activity, Jupiter's clouds show biologically permissible water activity levels, but only within a temperature range of 10 degrees Celsius to 40 degrees Celsius. But researchers note that this is only the first level in assessing cloud habitability, as chemical components in clouds could also affect it. Similarly, water activity in Earth's atmosphere is suitable for life, but only in the lower troposphere, with the upper and middle layers being too dry to be habitable. For other planets in the solar system including Saturn, Uranus, and Neptune, there is currently insufficient data on atmospheric consistency to perform such an analysis. Although this may change in the future, especially with observations from the James Webb Space Telescope and Mars. Does not mean life in these places is entirely impossible, only that it must be very, very different from any organism known to science.